Let me first welcome you all to this new session of our student conferences. Today we have with us Professor Vinita Damodaran of Sussex University. I'm just going to briefly introduce our Professor Vinita Damodaran, and then I'll give her the floor. And at the end, we'll have some time for questions and answers. So very briefly, Professor Vinita Damodaran from the University of Sussex is a historian of modern India interested in sustainable development dialogues in the Global South. Her work ranges from the social and political history of Bihar to the environmental history of South Asia, including using historical records to understand climate change in the Indian Ocean world. Her publications include Broken Promises, Indian Nationalism and the Congress Party in Bihar from 1992, Nature and the Orient, Essays on the Environmental History of South and Southeast Asia from 1998, but also more recently, East India Company and the Natural World from 2014, and Geography in Britain After the Second World War from 2019. Today she will be doing a presentation entitled Historical Climate, Vulnerability in South Asia, Floods, Droughts, Famines and Cyclones. Please, you have the floor.
Thank you very much, Barbara. I mean, I've met Barbara before, and it's a great pleasure to come back and to chat to you all, albeit virtually. So this is a sort of a project, and I'll start sharing my screen. Which I've been engaged in for a while, where I'm linking natural history archives with manuscript archives. So climate history has become very, very fashionable, and precisely because, of course, it's not surprising because of the current environmental predicament that we are in. And if you look at the impact of rising flood levels or sea rise on cities in South Asia, particularly, or Asia, you have a very, very dramatic sort of prediction. So in flood-prone cities like Ho Chi Minh, Calcutta, Dhaka, Manila, potential sea level rise and increased frequency and intensity of extreme weather events poses significant adaptation challenges. And the people who are going to be affected by this, of course, is the urban poor living in riskier urban environments or floodplains, people with who are members of the informal economy with fewer assets. So the predictability of these events is becoming very important, which is why a lot of climate scientists have been contacting historians, and historical data available for these climate anomalies is very limited. And we've suddenly become quite important to historians. And I have a MOU, or a Memorandum of Understanding, with the UK Met Office to link South Asian historical records to climate change. So that is where I am coming from. So what are the sources and themes for such a climate history? And as one of the things that we've been sort of engaged in terms of our working with the UK Met Office is in collecting shipping data, ships logs. And the project of the Met Office is called ACA, which is atmospheric reanalysis programs, which are using historical data rather than just models which are based on actually having real data to feed into climate models, as it were. And this climate archive project has been quite successful, and we've been helping them to look at particular periods, especially in the pre-instrumental period, which is before the 1880s, by collecting precipitation data, everyday mean temperature and precipitation data. So the sort of sources we've been looking at, as I said, are ships logs, documentary sources, including and paleo sources, and some secondary sources. And some of the secondary sources that we've been engaged in collecting include writers, historians such as Roy Ladourie, Parker, Geoffrey Parker, De Veres, Clinging Smith, Grove, John F. Richards, who've all sort of looked at climate data in this fashion and to link it up to socio-economic phenomenon. So this is no longer a sort of determinist exercise. This is much more of a useful exercise, and historians are beginning to recognize it as such. And the themes then that we can look at for this presentation is, for example, the 17th century crisis, looking at the impact of global cooling in Asia in the context of the 17th century crisis, which is meant to be a European crisis, by looking at sources of the Mughal Empire in Asia. 18th century, whether there was a difference between the 17th century and the 18th century, because for Europe, the 17th century was seen as a period which was different from the 18th century, a period of great crisis. So can we say the same about Asia? For the 19th century, I'm going to be looking at cyclones, and I'll be also looking at traditional adaptation and resilience by looking at some case studies, mainly in the Sundarbans. So I want to argue for the importance of South Asia for understanding global climate. One of the reasons is the monsoon, which is very, very critical to understand climate anomalies. And a lot of East India Company scientists or British Empire scientists were engaged in understanding the monsoon, and they feed into debates on global climate. So what we see as climate arguments now have a long history. That's the other point that I want to mention. So you get the emergence of colonial meteorological networks, you get an understanding of climate mechanisms. There's also, because of the empire-wide nature of this, you get an understanding of connections between different parts of the globe, right? So you get a global understanding of climate through the canvas of the British Empire. So importance of empire data is something that is important, that we need to accept. And also how this data sort of challenges Eurocentrism. So the importance of India and the Indian Ocean world for global climate is what I want to talk about. So talking about the secondary sources, as I said, this is not a new sort of area for historians. The famous writer Roy Ladourie of the Annals School had looked at in his classic book, A History of Climate since 1000, had first argued for the links between climate and socio-economic history in his text called Times of Feast and Times of Famine. But the more recent book of Geoffrey Parker, War, Climate Change, and Catastrophe in the 17th Century, if you haven't had a chance to look at it, is definitely worth looking at. So what do we know? What can we say about climate and weather? So climate and weather are very complex and very complex and vary through time and geographically. Therefore, to collect a lot of useful data, you need a lot of data points. So these data points are provided, as I said, through empire. So you have lots of possibilities for observations and an information flow network, right? So the world's biggest weather phenomena are the monsoon systems, the seasons, and of course, ENSO, which is the El Nino phenomenon of warming of the oceans, as we know. And these are allowed for by, as I said, the way in which we can collect data. And the documentary sources that we've used for collecting such data include, a lot of archival sources, for example, for the EIC records. And we've done this at the Center for World Environmental History, which I run. And there are many sources we've been collecting through using graduate students from the Mughal Empire. So we've sort of created a sort of database for this climate history, looking at documentary sources. We've got a paleo historian involved on the project, so we've also collected secondary paleo sources to see, for example, what the records are for, say, 14th century in terms of lake data, lakes, or we've also looked at speleothem data and then connecting it to manuscript archives. And thereby we've been able to construct a sort of coincidence between the natural archives and the manuscript archives for the 17th century in terms of floods, droughts, and famines. And this has been extremely interesting, and I'll come to some of our analysis in a minute. And we've sort of created a timeline of events, and you can do this for most parts of the world if you link up with climate scientists. So the term monsoon then from the Arabic mawsam is a season. And as I said, the key to understanding world climate is understanding monsoon. So the Indian Peninsula is key to understanding world climate. And when we talk about the importance of South Asia, this is what we're talking about. And the main features of this climate network, or the understanding of climate and how it's globally teleconnected, was discovered by Indian civil servants and officials. And these included Scots, who are based in India, Germans who are based in India, and Bengalis, so local Bengali speakers. So how were these Indian networks built up? What contributions were made by the rest of the British Empire and other colonial empires? This is an important question. And many of these networks were made up of, for example, Moravian missionaries. So missionary networks, I think, are quite important. Danish and German networks in Tranquebar or South India. And what they were doing, what these sources reveal, is they're measuring cyclones, they're measuring droughts and grain supply. And the idea of meteorological observation or natural history observation from Protestant Halle, plus data from East India Company ships, provides quite important granulated sort of data. In Madras, Geisler measured cyclones, information also from Moluccas and Tranquebar, which was a Danish colony, and you have also had German missionaries. But there were some key individuals that were quite important. William Roxburgh, in Richard Grove's work, made the global linkage for the first time between India and the world. And he, of course, can be seen as the first climatologist and climate historian who was able to understand the 1790 crisis through a sort of the global network of climate. So you could see the drought in India equated to drought in South Africa. So these sort of global connections, someone like Roxburgh was able to make. And Roxburgh is quite important because he was the head of later on became the head of the Calcutta Botanic Garden. So these botanic gardens are also very, very important because they're collecting daily and sub-daily temperature and precipitation data as well. So the importance of connecting weather across and climate data across the empire, you can see how the links between Roxburgh, the other important people that we are talking about here are people who are in Australia, people like Charles Todd, who are equally important. So there is there's a whole group of individuals, mainly men, of course, white men, who are able to connect, as I said, the data. And as I said, botanic garden observations are important. Roxburgh gives weather a long time perspective. And he's able to connect drought on St. Helena through the work of, say, Alexander Beatson to drought on Montserrat and droughts in India. So these sort of global connections, I think, are very important. So Alexander Beatson is another person that we need to recognize. Of course, there's an earlier history to this. Edmund Halley in 1676 estimated the amount of salt in the world's oceans. One of the characters we're going to encounter a little more is in 1798, who collects a lot of data between 1798 and 1852 is Henry Piddington, who collects information on cyclones, and Charles Meldrum, who becomes quite an important player in the Met Office. So by 1852, you have 123 weather stations in India. The center of calculation is at Calcutta. And the Himalayan data is collected by the Strachey and Schlackwhite brothers. Indian princely states also are collecting data. For example, the Raja of Travancore is appointing a meteorologist. 1846, the Madras government sets up Nilgiri Observatory. Blandford is appointed as government meteorological reporter, In terms of technology, the telegraph is used to transfer marine and regional data to Calcutta to predict weather and cyclones especially. So by 1871, weather instruments are standardized empire-wide. 1877, William Hunter connects droughts to sunspots. 1878, the first photos of the sun are taken by John Waterhouse. And 1877, the Indian Met Department is established, which makes links with Australia. So the importance of data collection and empire is what I've emphasized so far, and the importance of particular individual networks, including Roxburgh's networks. Those are the sort of things I've highlighted, and how that data was collected, both through ship's logs, as I said, and through botanic gardens, and through just assiduous collection of data through in the context of empire. So what does that sort of data sort of tell us? And I think when we look at, if you look at the more recent knowledge that we've had on ENSO or the El Nino Southern Oscillation, we can find that some of the data they're collecting equates to what we now know about ENSO, which operates in two distinct phases alternating over a period of 2 to 7 years. These phases are characterized by warming in the tropical Pacific and the Indian Ocean, which often suppresses rainfall in the Western Pacific in the case of El Nino, and converse in the case of La Nina. So you get droughts, floods followed by droughts, or vice versa. So, and this phenomenon of ENSO, which we know now varies widely in their manner of expression or centers of action, duration, and depth, but are typically accompanied by extreme weather events. So the links, and so someone from the UK Met Office, who we collaborate with quite closely, Rob Allen, talks about the links of El Nino with sea surface temperatures and with the Indian monsoon, and how the Indian Ocean is linked to the phenomenon quite closely. So these scientific sort of data is something that we have come to understand. But what is interesting for us is how this data that we now know on ENSO links up to the data collected by these East India Company scientists in an earlier period when less was known about this phenomenon. So ENSO examples detail the resolution of both that we're going to look at the reconstructed El Nino and La Nina, longer protracted episodes. So what some historians have argued was an El Nino period in 1790s was actually a protracted El Nino, where you had floods followed by, or La Nina followed by El Nino. A protracted episode is defined as a period of 2 years or more when measures of the phenomenon and various precipitation extremes persist, that is drought or flood. So some of the data we've collected from existing databases like the South Asian Monsoon Index, which captures 18 of the 26 recorded famine events over the last millennium. Notably, 11 of the 16 short events with durations of 1 to 3 years are accurately depicted in the reconstruction. And so here you can see from that the South Asian Summer Monsoon Index, which is Shee and Wilson, how El Nino and La Nina can be depicted, and how these are recorded, and how it sort of coincides with famine. I think this is a very important sort of chart for us. This slide shows us how the decadal events are reconstructed between 1525 and 2000, and you can see that there are particular periods when you have very strong or extreme El Ninos, and again when you map the El Ninos that have now emerged from, or El Nino data that's now emerged from the Met Office to socioeconomic events, you can see whether the natural archives coincide with the manuscript sort of data that we've got. So some of the El Nino events, 1659, we've sort of calibrated for the Mughal Empire. And we've seen that this was a period of, those periods, some of those periods are periods of extreme famines in the Deccan. And so they do coincide. So to say that it was all a result of Mughal policy may not be correct. There is a climate trigger to some of these episodes, which are there in the natural archives. So 1659 to 1661 is an El Nino period in the record, 1650 to 1652, 1618 to 1621, and 1607 to 1609. So I get a lot of scientists now contacting me, and recently we've just finished a paper for Science Advances on the 15th century to say whether particular periods, because their speleothem record is showing droughts, whether that does coincide with famines or violence and so on. This is another Palmer Drought Severity Index map for Madras. And it's very interesting if you look at 1769 to 1773, the Bengal famine, which killed 10 million people in Bengal and Calcutta. It's not a severe drought. So sometimes the data reveals that this might not be necessarily caused by climate. This probably is caused by socio-political events. And I think, looking at the data and comparing it is very, very useful for us. So according to the Palmer Drought Severity Index, the Ming Dynasty drought is clearly shown, the Bengal famine, the little bit of drought, but not really obviously. So what was the reason for the drought is again quite interesting and important. So the question that I asked you in the beginning, I raised in the beginning, was whether the 17th century crisis, which was a period of global cooling, is prevalent in India or South Asia. This idea of a general crisis, the notion of crisis is a fundamental transformation between two epochs, between old and the new, which dominates the historiography of Europe. Is that true for Asia? And from the data that we've looked at, it appears to indicate that the mid-17th century saw the weakest period of monsoons. So there were, and if you look at the ENSO examples, El Nino and La Nina, you do get protracted episodes you get occurring every 2.5 years, half the 5-year average. So there was some climate problems in that period. What impact did these climate events have on India in social and economic terms? And if you use Parker's work, he talks about the Little Ice Age to climate conditions between 1610 and 1708. And he uses the term in the context of greater climatic variability, reduced solar energy being only one of them, increased volcanic activity, and a greater frequency of El Nino. So for him, it's a lot of factors that cause climate variability. And these years of the Little Ice Age coincide well with those in the Mughal Empire. The Mughal Empire also experienced episodes of severe political disruption, resulting in widespread violence. So according to Parker, the Mughal Empire can be seen as having come close to revolution in the 1650s. And the 17th century as a whole was a period where wars were fought almost continuously. So there's a coincidence of what's happening, say, in Europe to what's happening in the 1650s in South Asia. And there are droughts, floods, and famines, particularly in the 1620s, early 1630s in Gujarat and Deccan, which he cites. This period, so Parker then is talking about linking climate to this period of exceptional violence in the 17th century. And he says that for Europe, but can we say that concretely for the Mughal Empire? And here, because remember, Parker is not a historian of the Mughal Empire. He's just making these connections and claims. And if you look at Mughal Empire historians, such as John F. Richards and Irfan Habib, they in fact describe the period as being one of relative calm and stability. So this idea that the 17th century was a period of exceptionalism is not necessarily proven, though there are sort of increased droughts. The period of horrendous violence that he talks about is not borne out by the experts in the field, right? So for historians such as David Klingsmith and Jeffrey Williamson from Harvard, they argue that it's the 18th century which saw the most significant upheavals in India's economic and political structure. That was the end of the Mughal Empire. And therefore, they say it's not the 17th century, it's the 18th century that becomes much more significant in terms of upheaval. So here again, climate data, and when you try to analyze climate data in the context of socioeconomic data, the jury is still out. It's not easy to say that the 17th century was an exceptional period, as Parker has tried to do in his gigantic book, War, Climate, and Catastrophe. And if you look at the 18th century, then you have 12 famines from 1765 to 1858, 4 severe scarcities. Indian communities were disturbed by the interventions of the East India Company. And here you can see real socio-political reasons for the crisis, perhaps. Increased taxation, increased sedentarization, attempts to restrict raids, hunting nomadism. As environmental historians, we would see increased deforestation, right? So then here, cultural, societal, political, and economic factors loom large. And climate appears to have played a relatively insignificant role in 1770 famine, which was one of India's most disastrous and costly famines. So this is quite an interesting sort of narrative for us to say that, hey, we can use climate data, but as historians, we have to be quite selective in how we use it, right? But then we come to another period, which is the 1790s, which is, I'd mentioned Roxburgh, which Roxburgh sort of worked on quite extensively. And this period, if you look at the famine reports, they talk about particular famines that hit the 1790s. And here we can see that climate does have an impact. While for the 1770 famine, it doesn't have so much of an impact. Climate does seem to have an impact for the 1790s. And 1780s and 1790s in particular. And if you look at the famine map of India, you can see there is quite a dramatic change, and or you can see how all these areas are sort of teleconnected or linked in terms of the 1780s. And if you map it to other places, and we've done an article on this recently, if you look at compare India to Sydney, to Africa, you can see that there are reasons to believe that El Nino and La Nina did have an impact on global droughts and floods in the 1780s. From 1783 to about 1793, so 1780s and 90s. So for example, I quote here from F.C. Danvers, there are reason to believe that the upper parts of Hindustan had been visited with extraordinary drought during the previous years. In October 1783, there was an abnormal cessation of rain, an extreme drought, and a terrible famine. To the northward of Calcutta, the crops on the ground had been scorched and nearly destroyed. The long drought was succeeded by great floods. In Sydney, where the nascent colony was settling itself, they talk about inclement, tempestuous weather throughout the winter of 1788, making life in the colony difficult. And not only did much heavy rain fall, but the work was prevented, was made fruitless. I quote, the brick kiln fell in more than once, and bricks to a large amount were destroyed. The roads about the settlement were rendered impossible. So the settlement of Australia during the period of this protracted El Nino La Nina event was quite difficult. Sharon Nicholson, the great historian of Southern Africa, has talked about eastern equatorial regions in Africa experienced a preponderance of drought in the period. In western half of Africa, the opposite appears to have occurred. But she concludes that there was an unusual forcing of conditions in the 1780s. So in many ways then, during the 1780s, climate historians have resolved two protracted episodes, a protracted El Nino from 1782 to 84, and a La Nina, that means drought followed by floods, from 1785 to 1790. And so these protracted episodes seem to have crossed these unsettled conditions from India to Australia, to parts of Africa that Sharon Nicholson has worked on. And in India, you get 1783 to 84. You get the droughts that are being analyzed, called the 40-year drought, the Chalisa famine. By 1784, the famine was over. But this long drought was succeeded by great floods, a classic El Nino event followed by a La Nina flood. And this flood was recorded by Roxburgh, the great meteorologist who later became the director of the Calcutta Botanic Garden, who I mentioned earlier. And he talks about this great flood in 1787, which coincided with a tropical sort of cyclone and resulted in 20,000 deaths. So much of the reports that we've collected show that this was a very unsettled period, 1787. The Madras typhoon was reported. So this extended ENSO episode that I've talked about seems to have been represented in much of the manuscript archival material in Campbell's work, Report of Floods, General Letter from India, 15 December 1787. And the recent advances in the reconstruction of past ENSO conditions, I think, prove the fact that this was a very, very unsettled period. So Jurgis and Fowler conclude that a very strong La Nina event, not El Nino, was centered on 1788 and spanned to 1790. So you get a El Nino followed by a La Nina. So I think this sort of phase is something that we really need to understand and emphasize. So that's where the climate scientists become quite important for us. So working on these climate projects, unfortunately, is an interdisciplinary exercise. And not only do you need to refine your data as historians on social and economic conditions, but you need to get inputs from climate scientists, especially to check the climate data, which we have done because we work collaboratively here with Professor Rob Allen at the Met Office. So to go back to some of the key questions that climate scientists are raising, are tropical cyclones increasing? If you look at the data, so what we are doing is collecting citizen science. Have there been cyclones in the past, right? What are the impact of these cyclones? So we can get data from our manuscript sources that tell us about this. So when climate scientists are arguing that tropical cyclones are likely to increase because of greenhouse gas emissions, and that the increase will be about 10 to 40%, is it sort of proven from the historical record? And he's, of course, basing it on computer models. And what does the historical record sort of say? So cyclonic history, again, is an important theme when we understand. And cyclonology as a term was invented in the Indian context, where, again, as I said, empire-wide data is very, very important. The data collected by East India Company scientists. And Piddington, I mentioned Piddington, who was writing in the early part of the 19th century. He becomes the very preeminent cyclonologist. So how do we sort of link cyclone history to the El Nino history? So it's quite important to understand that gathering more documentary data on ENSO-related events allows us to understand tropical cyclones and their impact in South Asia in the 18th and 19th century. And again, by using colonial collections of the British Empire, this is a way of understanding past and future climates. The other material we've also been collecting is on earthquakes. And one of the earthquakes that we looked at was in Western India, in Rajasthan, in the Rann of Kutch, where in 1819, an earthquake of some dimensions hit Bhuj, killing 2,000 people in 1819. The earthquake was followed by heavy rain for 2 months, the frequent failure to plant crops, and which resulted in famine-like conditions. And those particular disaster events and the adaptation strategies of communities, again, feeds into the current adaptation literature. So here we are understanding climate change from below, from pastoralist communities, from what's happening to local grasslands, people's migratory patterns, nomadism as a way of adaptation and a way of resilience. And I think once again, looking at the historical record to understand adaptation and resilience is important. And here we've used the example of the 1819 Kutch cyclone to understand adaptation practices among the Bunny tribesmen or nomadic pastoralists. In another area in eastern India, where we've looked at the Ganges, Brahmaputra, Meghna Delta in the long historical time frame. This is one of the areas which is predicted, and of course part of it is in Bangladesh, predicted to be swallowed by rising sea levels. And the population that's threatened is about 22 million, which is why collecting the data on cyclones is important for climate security, for migration and settlement research. And it's a sinking delta. And so we are rapidly collecting the history of this sinking delta of over the last 200 years at the moment. And this has impact on Calcutta, one of India's major cities, which is over 14 million people, the third largest metro in India, one of the largest in the world, on the banks of the river Hooghly in the Ganges Delta. Of course, it's suffered from poor large-scale land reclamation and poor drainage. What we've done to all our cities, horrendous. And what impact is the current climate change impacts of rising sea levels have on it. Calcutta is located, of course, 154 kilometers upstream from the Bay of Bengal. It's a compact city concentrated along the fringes of the Hooghly River, pink and blue on this map. The surrounding area is a flat, swampy region with a subtropical climate. And the impact of cyclones in this region has not been studied. But what we've been doing as historians is collecting the data that Henry Piddington collected as a cyclonologist between 1798 and 1852. And we've come up with some extremely interesting material on cyclone history through looking at this archival data of colonial meteorologists. And his book, The Law of Storms, I think is very, very interesting. The other person we've looked at is Charles Meldrum, who started off as a main player in the Met Office, and he collects climate data on the Indian Ocean in the 1860s. Cyclonology was his principal field of research, and he made full use of ship's logs. By 1868, Meldrum had quite an impressive amount of data and pushed daily weather charts of the southern Indian Ocean, drawn retrospectively for the year 1861. But the main result obtained from his patient work on these charts was to establish the law and direction of cyclones across the Indian Ocean. So this material is actually very, very rich for cyclone history. And through their writings, we can, this was the map that you used of the 1864 Calcutta cyclone, which this is again citizen science. These were paintings and images from newspapers which were drawn of the 1864 cyclone, which as historians we are collecting as part of our database exercise. And you can see the impact of the cyclone, both from ship's logs, from local newspaper sources, to draw up an understanding of the cyclone. And this is an inundation map, which is again very useful because we can compare the inundation to the recent Amphan cyclone that hit Calcutta recently, and comparing a cyclone that hit Calcutta recently to the 1864 cyclone allows us to deliver very, very useful information. And I think once again, the cyclone Amphan, I think, which was super cyclone in the Bay of Bengal, and the mapping of that with the mapping of this will yield, and we haven't mapped the impact of Amphan in the way in which this map has shown us yet, but this will yield very, very important sort of results. So the official death toll for the 1864 cyclone was 48,000 people. That is 1/3 of the population of Calcutta. This is really shocking. It wasn't a major cyclone, it wasn't the level 4 cyclone or even a level 3 cyclone. It was a level 1 cyclone, speed of 10 miles per hour. The storm had a width of 100 miles, but it's still, the dramatic impact was caused by the pulling of the cyclone into the environments of Calcutta through the river Hooghly. So the river Hooghly sort of drew it in and caused the greatest amount of damage. So when we look at Henry Blandford's Origin of a Cyclone, Proceedings of the Royal Society of London report, they argued that the barometric pressure was very, very low, and they managed to collect the data on barometric pressures through ship's logs. And I think this is, again, very important that ship's logs are being used, and we have the shipping data from one particular ship that shows us and maps the origins of the cyclone in great detail. And this, it also, these are images of the damage caused by the cyclone. The contemporary reports, as I said, are Henry Blandford, and local reports by people who saw the cyclone. As measured by Mr. Whittle, the height of the storm wave at Diamond Harbour was 4.58 feet over the top of the bund, therefore allowing 8 feet for the height of the embankment, about 12 feet 7 inches above land level. So very meticulous data, or citizen science, what we now call, is made available by these reports. Henry Blandford noted, recording the contemporary sources, a storm chart of the Bay of Bengal drawn by Mr. Pittington shows that the majority of the cyclones, the tracks of which are there laid down, proceed from a line running straight south to north by the Nicobar Andaman Islands of the Arakan coast, following the westward side of the mountain axis, which is part submarine, is a prolongation of that of the Sunda Islands. Of these storms, several appear to have originated in the neighborhood of the Andamans. So here, very precise data about how these cyclones originate and where they originate, the barometric pressure that's measured, the diminution of barometric pressure, small at first, but becoming more marked with the continued operation of the preceding cause, so that after several days, it might become capable of causing that extensive in-drought of air, which appears to be the immediate antecedent of the formation of a cyclone vortex. So this is cyclone science, as we see it, meticulously documented by citizen science, as well as by cyclonologists. You also get the reports of the cyclones from a lot of newspaper sources, wherever there were trees, and this is the New York Times 1764, the Calcutta cyclone. Wherever there were trees, they were either uprooted and fell, carrying with them, in many cases, walls, railings, and buildings, or their branches were snapped off like reeds and hurried away with the wind. Carriages and palkis were upset. Palkis are, again, another word for palanquins. The roads mingled with the debris of roofs, verandas, gates, and fallen trees. Corrugated iron roofings were torn, doubled up, and blown away like sheets of paper. The casualties, as I said, for 48,000 people. In Calcutta alone, 102 pakka, means houses which were strongly built, were destroyed. Remember that a lot of them were shanty towns, so the damage would have been much more in terms of 40,698 native huts were completely leveled. One interesting source is the Clarence, which is a ship that had sadly docked there in 1864, but couldn't land because of the cyclone. And Clarence, looking at the ship's logs from the captain of the ship, James Watson, he gives you hourly readings of wind and the barometer. This is the sort of material that the Met Office wants us to collect. But the interesting story about Clarence, I think, is quite important for us. Clarence leaves London to go to Calcutta, and it's with the 7th Hussar Regiment. So it's dropping off military men in India to serve the interests of the British East India Company. But when it arrives in India, they can't dock, so they are waiting in the dock. They witness the cyclone, and once the cyclone is over, they pick up 500 coolies to take to the sugar islands of the Caribbean. And when they reach St. Helena, they stop. because there's a fever raging on board. So the ship is not allowed to land in St. Helena, so it docks there for a month. By the time they're allowed to move on and arrive in the Caribbean, 3/4 of the coolie population have died of cholera. And 12 of the staff are also ill. So the ship then drops these surviving coolies off. Of course, all the dead have been thrown into the sea, and brings sugar back, and finally docks in London. So the voyages of the ship Clarence epitomize empire as well, and the way in which labor and resources go into the making of empire. But we can use these sources to understand, as I said, climate and the cyclones, and the damage here was carefully mapped in photographic evidence as well, local photographs. One thing that we do come across is the narrative about Port Canning. Port Canning was built against Piddington's sort of advice. He did advise them that building a new port in Calcutta would be dangerous. And of course, Piddington was right. A terrible mass of salt water rolling in or rising up with such rapidity that the whole settlement will be inundated to a depth of 5 to 15 feet. Piddington had predicted in 1853, right? However, the hubris of empire meant that the port was built, and in 1767, the port was wiped out by the second cyclone. So Piddington was proved right. So cyclone science, important. So Piddington sort of predictions, important for this for Calcutta then, and the hubris of a port building then. But what will happen if you have current climate change induced cyclones is only left to the imagination. And I think this is a very salutary story about Port Canning. In 1876, you get another cyclone, and this has been covered in a recent book by Benjamin Kingsbury, The Bengal Cyclone of 1876. Here, the death toll is much more. Of course, it's here the waves swept away everything in its path, drowning 215,000 people in eastern Bengal. So this includes the Sundarbans. It's not just Calcutta. The tides were at the peak. But Kingsbury, the author, turns the interpretation of natural disaster on its head, showing that the cyclone was not simply a natural event, and I think we can learn from him, but one shaped by the all too human pattern of exploitation and inequality, by divisions within Bengali society and the enormous disparities of political and economic power that characterize British rule on the subcontinent. I think this is a very important point, a salutary point for us about how the impact of climate change today will be felt unequally by different groups of people. And as the great writer Amitav Ghosh has said, that 50 million people in South Asia will be seen as a sort of sacrifice zone, while the rich and the more wealthier sections of society might survive. So the official policy in 1876, which exacerbate the cyclone, which Kingsbury has outlined, I think emphasizes this inequality of natural disaster argument. We are not all in it together, which the global climate people like to tell us. Some of us are in it more. So we can see this in the 1876 cyclone: failure to remit taxation, the salt tax of 650%, ruthless laissez-faire policy of the colonial state, poor relief efforts, poorly maintained embankments, warning systems which failed, meant that the poor suffered abnormally. The dead and dying number 215,000. Including 100,000 dead by cholera. So including disease, I think, is quite important. So our cyclones intensifying, 1864 and 2009, Cyclone Isla were 11-1 cyclones. Cyclone Amphan was more major. So how would that, and actually did cause the cyclone, it was a super cyclone in the Bay of Bengal, which intensified from a cyclonic storm in less than 36 hours into a super cyclone. It went on to make landfall over West Bengal and winds close to 155 kilometers per hour. So that was a much more dangerous cyclone. And but if you get it, but it was still not a level 5 cyclone. And the impact of the cyclone, I think, would in more recent times is increasing. So I think the argument whether cyclones are increasing, the answer is correct, that the cyclones seem to be increasing. In the case of Calcutta, though some other experts would suggest that we cannot yet detect any increase in tropical cyclones, but the jury is out in terms of in the last 10 years, Calcutta has been affected by 2 cyclones in 2009 and then last year more recently. So 2 cyclones in 10 years of varying intensity. So how do we then answer these questions that are raised by climate scientists? Are cyclones increasing? Is by improving the historical weather and climate database that will provide a platform with which to address key concerns in climate change. And the impact of extreme events, this collecting this data is very, very important, because the impact of extreme events on countries like South Asia is enormous because of population densities involved. So to conclude then, the scope of historical data available to refine climate anomalies is underestimated, and large amounts remain untapped. But with concerted data rescue activities, this situation can be dramatically improved both back through time and wider in space. As extreme events increase, the predictability of these events becomes more important. At the same time, there's a creeping uncertainty. Therefore, improving the historical weather and climate database will provide a platform to address key concerns of climate change. At the same time, the archive also yields very, very important data on climate adaptation and resilience. The Center for World Environmental History, as I said, is engaged in looking at this. And I would urge all of you, if you're collecting data in different parts of the world, to improve your collection of famine series, of price series, of migration series, which is taken for granted in the European context, but in the African and the Asian context, and link it up to climate series to improve our understandings of global climate. And I'll stop there.